Problem 12. The area of rectangle ABCD is 1,000 centimeter. Find the area of the shaded part. Okay, they have EF is parallel to DC. Okay, let's first look at the top rectangle. If for the shaded area, we have this base as A, this middle base B, and this small base of C. Let's call this height H. So the three triangles area adding together is how much? 1/2 AH, base multiply height. Second, 1/2 BH. Third, 1/2 CH. And we have the distributive property reverse. That is, we take out 1/2 H. Then we have A plus B plus C. That is 1/2 A plus B plus C, that's AB, right? So the shaded area of the top rectangle equals to half of the area of the top rectangle. We can do the same for the bottom one. We say this is X, the base is X, this is base Y, this is base Z. The shaded area has, this is, we call that this H, we call that P. The height is P. So then the three shaded triangles of the bottom rectangle is 1/2 XP plus 1/2 YP plus 1/2 Z of P. And we take out 1/2 of the height, then we left over is X plus Y plus Z. And then X plus Y plus Z is again AB. So this says the shaded triangles on the bottom is the half of the lower rectangle. Therefore, all shaded part together is 1/2 of the total. So that is 500. Practice problem 13. The rectangle ABCD is divided into 4 different parts, 1, 2, 3, and 4. And we have S1 plus S3 equals to 50 centimeters squared, and S2 is 21. Find area of S4. So using the same property that we showed in problem 12, students should be able to find out quite easily. Okay, let's give some hint. We have S2. If we call this one as A, the length is A, and the width is B. S2, if we call that height as H1. S4, the height is H2. So S2 area plus S4 area equals to 1/2 AH1 plus 1/2 AH2. We collect the same term, which is 1/2 A. We left with H1 plus H2. H1 plus H2 is what? B. That says this top triangle added the bottom triangle equals to 1/2 of the total rectangle. S1 plus S3, students can follow exactly the same strategy to find out these two equals to exactly the other half. Therefore, since you know S1 plus S3 is 1/2, that means S2 plus S4 is the same. With S2 known, you can easily find S4. Practice problem 14. In parallelogram ACBD, the EF is parallel to AC. Connect all these different joints. We will find all the triangles that have the same area as BEC. What is BEC? B, E, and C. This one. Okay. So for triangle, we have 1/2 A multiply H. We look for triangle that has the same base and height. Okay, for BEC, this is the base, for example, and we have a height here. Then easily we can see that the triangle ACE has the same base as BCE and also the same height because this is a parallelogram. So triangle AEC would have the same area as BEC. Now let's look for what triangle has the same area as AEC. AEC, if we look at the base as AC, the height is this way, then there is a parallel line. We can see that FAC has the same base as AEC and the same height. So therefore, FAC has the same area as AEC, therefore same area as BEC. Let's look for whether we have any other triangle that has the same area. So now, if we look at this one as the base, triangle AFC, and we have triangle ABF. They have the same base, and they also have the same height. Right, from this point to there, from this point to there. Since this is a parallelogram, the height is the same. So the last triangle would be A, B, and F. So we highly suggest that students can go from counterclockwise or clockwise in order not to miss any triangle, because this problem is you can easily miss one of them.